Let's wait for 1 more minute. Then after that we will start the session. Okay. So I'm starting the session. So my name is Satyakam Pratap Singh, and this is the fifth tutorial session of the network analysis. Uh, the host structure is Professor Kumar Bhattacharya sir from IIT Kharagpur, and I am Satya. I am a PMRF research scholar at Department of Energy Science and Engineering, IIT Bombay. Okay, so before starting the session, I will tell you that last time we have studied few of the topics related to network analysis and all, like how to solve the differential equation, how to solve the zero values theorems were there, and some of the we have seen the word how the apply the superpositions and all. So in this tutorial session, we will see how to solve few of the numericals, which will be helpful to solve the assignment 5. Okay. So before moving forward, so there were last in the last tutorial session, there were few problems which were left. Okay. First, we will solve that. After that, we will jump to the tutorial 5, and which will help to solve the assignment 5. So I am putting forward the first type of question. Okay, please try to solve and let me know if you face any difficulty. Okay, you have to find out what's the RMS current of RMS value of the current IT. If you face any difficulty, just let me know, and you can open your chat box as well, and write in that, and you can also open your mic and ask me anything if you have any doubt. No problem. You can take your time and solve. There's no problem. You can guess it also and try to solve the mind itself. Okay. I will give you few minutes. Let me join. In between, I will wait for this if anybody else can join. Okay. After 1 2 minutes, I will solve this problem and give the solution itself. Okay. Okay. It's option B, and I got one answer. Okay. Let me give the solution for this problem. Okay. So what is saying in this question that you have to find out the RMS value, basically RMS value of IT. Okay. So this is the one thing that you have to find out the value of RMS in this term. So, so if you see the circuit is looking like this. Circuit is like this. There's a R term here, and one resistor is here, and one source is here, AC source. Okay. So this is the positive terminal it is giving, and also the value of the sinusoidal term the is 190 volt. Okay. And this is the current IT which is going into this circuit. Okay. So in the last problems itself, which I have told that you have to take the one reference and always take that current is leaving outside of that terminal. Okay. Suppose I wanted to apply KVL here, KCL here basically. Suppose this is node A. So at node A, apply KCL. Okay. Let's take this node as a reference. Okay. So how to find out? Always assume that my what I have told in the last one, always assume that current is leaving that load. Current leaving that load, leaving the node. Okay. So when you apply the KCL, how? Because the IT, if you see here, it is actually coming into the circuit. Okay. So it is actually minus IT. Okay. And let's assume that this is a voltage V. Okay. At this terminal. So this V minus 0 divided by 1. So this what amount of current go into 1 ohm resistor? It will be V minus 0 divided by 1. Okay. V minus 0 divided by 1 plus if you see this capacitor and this inductor, it is actually represented because the capacitor will be represented at minus j upon omega c in the Fourier terms, or you can say here like this. And here the farad is given omega. If you see here, this sine t usually represented as a sine omega t. Okay, here the omega value is 1. So the same frequency will be followed in the circuit itself. So it will become minus j upon c. C is actually 1, so it will become minus j. Okay. What about L? L is usually represented as j omega L. Okay. So here the j omega is 1, L is also given 1, so j. Okay. So the whole circuit, if you see, what is the impedance here? So it will be V here, voltage at a node A, that is V minus 0, because the current which I am assuming it's out of that node. So divided by minus J. Minus J is the impedance of this capacitor, and J is the capacitor impedance of inductor. Okay. So how, if you see here, this minus J and plus J, it will become 0. So how the value will look like? IT plus V by infinity, basically 0 is equal to 0. So if you see this term, it is actually representing infinity, but current cannot be infinity. Okay, so where is the catch? Catch is the Z value of that node. Suppose this is A, this is B, and this is the line I'm representing at ZAB. So impedance, if you see minus J plus J, it will become 0. It means that it is actually open circuited. Okay, because the infinite impedance is there in line, so there will be no no voltage drop or anything happening in that circuit, and it is called no current is flowing, so it is open circuited. Okay, so if you see that if it is a open circuited, so all the current will flow from here. So the current will flow through this circuit only. Okay, okay. So what will be the value of current here? So let's find it out. ITs will be equal to 1 sine t, the current, divided by impedance in that line. What is the impedance? Here it is shown as 1 ohm. It will be plus 2, because the 1 ohm plus 1 ohm, it will become 2 ohm, will be equal to sine t by 2. So, but if you see that this is represented in terms of a sine omega t. So A is usually the amplitude. Okay. So the RMS value, look at here, RMS value will be equal to maximum divided by root 2. So L value will become equal to 1 upon 2 divided by root 2. Got the point? So it means that none of the options are correct. So B option can be correct if it is a 1 by 2 root. Okay. Any doubt?
So answering, sir.
Okay. Let me explain again. Duplicate it. What I've told that because if you see what I've told in the previous lectures itself, that when you are finding out the values of currents and all, so always apply a KCL or KCL at a particular node. KCL at a particular node, and assume that current is leaving that circuit. Assume that current is leaving that node. Leaving current is leaving that node. Okay. Okay. So it means that always assume that current is leaving that network. So if you see the nodes, if suppose that I'm taking here, I'm applying KCL here. So let's assume this is node A, and other terminal I have taken as a reference. Okay. So impedance, if you see of this line, what is the impedance of this line? Usually ZA, assume that this is B, ZAB, this line will be equal to minus J upon omega C plus J omega L. Why? Because in the Laplace terms also, I will explain what is the kind of Laplace and all. So when the inductor is represented as usually in the terms of SL, and S is usually the j omega. S is equal to j omega, and so it becomes j omega L. Same with the capacitor itself, it will be represented as 1 upon SC. So S is usually the j omega C, so it will become minus j upon omega C. So, but if you see the network ZAB, okay, omega is given here. If you see here, 1 sine omega t, 1 sine omega t means omega is equal to 1. Put the value minus j upon omega is 1, C is 1, j omega, omega is 1, L is 1. So it will become minus j plus j. It means that it is 0. Impedance is 0. Okay. Impedance is 0. It means, sorry, impedance is 0 here. So it means that it is short circuited basically. It is not open circuited. It is basically short circuited. Okay. So this is not the case of open circuit. When the impedance is 0, it is actually short circuited when the impedance is 0. If it is a Z is equal to infinite, then it becomes the open circuit basically. So if it is short circuited, so let's see the circuit again. So if it is a short circuited, let's take the another pin, black here. So if this circuit is short circuited basically, suppose this is shorted, so the whole current will flow through this circuit only because the load resistance path is provided by this short circuited path. So the actual circuit will look like something like this. It will look like something like this. No resistance drop here. The 1 ohm circuit which is there here, this line, this will not come in the picture because this is the only the low resistance path. So this is 1 ohm, this is 1 sin t, and this is the IT. Okay. So the current which is flowing in the circuit, apply the KVL. Yeah.
How Z is zero, sir?
Z is 0 because if you see the impedances, because two impedances were there. So let me take another slide for this. Explain that. So if you see the impedances which was there, it was like this. There was one inductor, one was capacitor, which was connected node, and here terminal I have grounded here. Okay. So this line which I was talking about, this in the means the Fourier terms, it will be represented like this j omega L. This will be represented as minus j upon omega C. So C was given as 1, L was given as 1, and omega, because the voltage is given as 1 sine t. So it is represented in standard form, the A sine omega t. So A is equal to 1 and omega is equal to 1. So that omega will be come here, okay, in these pictures. Same frequency, because the what the voltage generating at same frequency, the current will also be generated. So if you see the Z of this line, ZAB, it will be capacitor, inductor, which is coming j omega L, plus minus j omega C. So omega was 1, L is equal to 1, it became J multiplied by 1 multiplied by 1 divided by omega is also 1 multiplied by C is 1. So it becomes J minus J. So it becomes 0. Okay, this got
Okay.
cancelled. Okay, so it means that if it is 0, it means that it is basically short circuited path. There is no impedance drop. If it is a 1 ohm, it means that 1 ohm resistor is being dropped. Okay, if it is 0, it means that it is short circuited. If it is a Z is equal to infinite, it means it is an open circuit and no current is flowing into the circuit. Okay, so this means that if it is a short circuited path, it means that the whole current will flow like this, this current will flow like this. So the IT will look like 1 sine t divided by 1 ohm. It will be sine t. Okay, it is represented in terms of the A sine omega t form, which is standard, but the RMS is equal to maximum divided by root 2. Maximum, what is the maximum here? Maximum is 1 here. Okay, that is amplitude. So answer will become here this 1 by root 2 basically. Getting my point. See, actually, the what is actually the current is being transferred. If it is short circuited part, always take that as a lowest resistance path and neglect the other circuit which is in the parallel. It means that ki uh, suppose this is a one line which is a resistor which is a inductor connected and other circuit is short circuited, okay, and one source is connected. So the current which is flowing from here, it will always flow from the low resistance path. It will not flow in this circuit, okay. It will always it try to take the lowest resistance path. Take lowest resistance path, lowest basically impedance path, okay. So let's move to the next problem. So this is the next problem before you.
So
Yeah.
in general, current source will be open circuited and voltage source will be short circuited, sir.
No, the demand for this question is like this. Suppose this was a question. So the question was asking what is the RMS value of current. So
No, sir,
here,
I'm asking generally.
but when you are finding the means that equations which I have told that initial values and final values, that VT terms, okay. In that terms, it will be short circuited or open circuited, okay, but not in general.
At V infinity, voltage source will be open circuited now, sir.
No, here this is not a transient circuit. If you see that, this is a steady state circuit. So
No,
there
sir,
is
I'm asking generally for that equation
mm,
for
in
other
the
problem.
in that equation, yes. When you are taking that, then for finding the infinity values, then the inductor will be short circuited and capacitor will be open circuited. That's true. But there are two kinds of circuits usually possible. Let me duplicate it, take the explain it. So there are two kinds of
Sir,
circuit.
he wrote that equation, sir. That is it applicable for every concept or there is any exceptions like that, sir?
Yeah, let me explain. Okay. There are two kinds of circuit basically. One is a switching circuit, switching or you can say transient circuit. Second is the steady state circuits. Okay. What do you mean by switching circuits? Basically, suppose there is a one voltage source and there will be one switch connected, there will be resistors, there will be inductors like that. Okay. A steady state circuit is nowhere the switches will be there. Okay. It's just a simple circuit. But when you're finding this voltage VT here or a current across the inductor, here these equations are valid that I infinity plus I zero minus I infinity e to the power minus t by tau. But in the steady state, these equations are not variable, not come into the picture. These equations are only applicable in the transient circuits or switching circuits. But this is the steady state. So steady state, you have to find out directly the currents. Here, nowhere the e power t minus t to the power tau terms will be there. There is no switches to be closed. This is steady state circuit. Okay?
So we can't use that equation in steady state,
No,
sir.
no, no. You should not use because the switching circuit is usually represented in that e to the power something terms. That will not come in the steady state. Steady state basically the I infinity term. Whatever was there, the cycle ramps or anything was there, that will be applicable there. Okay, are you getting my point?
For so DC source is not a steady state, sir.
DC sources basically there is no concept of transient in the DC sources. So DC sources are basically like this. Okay, suppose there is a voltage of 4 volt across the all the time frame, it will be constant. But in this switching circuit, basically ACs, what happens? What we wanted a sinusoidal pure signal. But when you when you switch the circuit, it will move like this, and it come to the steady state. Okay, but this time frame, this is the time frame it will take to move. So basically, so it is a kind of damping down circuit. It will circuit will damp down the oscillations. So if we are damping down the oscillations, it is usually coming like this term, this form. So it means that's why we added two terms here. If you see the current equation also, it will, I told you it is I infinity plus I zero minus I infinity e to the power minus t by tau. So steady state circuit means when the time is tends to infinity. If you tend the time to infinity, I infinity will become simply means IT will become simply I infinity only. And when you put the infinity here, here it will become 0. This e to the power minus t by tau terms will become 0 basically. So it means that it already damped down that oscillations and came to the steady state where we can see that there is a pure sinusoidal terms were there. No e to the power minus t, no dropping down the voltages and all in the sinusoidal. Getting my point?
So the inductor and capacitor will work only under switching transient circuit, also.
Yeah. What equations I have told here, the to finding out the steady state and that values, that is basically confined to the switching circuits only, where you can finding out the infinity values, the capacitor will be open circuited and inductor will be short circuited. Not always, because the steady state is already at the steady state. It is already t equal to infinity time frame. There will be no transients and all. Okay, so then you have to apply the steady state formula like Laplace, like Fourier, kind of. Getting my point?
So in a steady state, inductor and capacitor won't work, also.
No, it will work, no, because the steady state, because the circuit which I have shown, suppose this is a circuit, okay? So this circuit, if you see, inductors and capacitor are coming into the picture, but they are coming in the picture, but their impedances, when they are added up in a line in the series form, it is becoming zero. But impedances are there. While addition, it is becoming zero. Getting my point?
So only at the DC circuits, inductor
Hmm.
and capacitor won't work when
No,
initial
no,
charge
it will
is
not
given.
work because in the DC circuit, inductor and capacitor, because they are the means they absorb kind of active powers and all. No, so if the flux is not generated, because if you have studied the Faraday's law, there is the EMF when generated when the flux got changed. Okay, when the in the DC terms, when the DC voltage is there, DC voltage there, the current will be constant. Okay, if they are resistive circuit and all, and inductor also, so there will be no flux change. Flux will be constant kind of, and then flux, if it is not changing, then EMF will become zero. There will be no voltage drop. Okay. Same happens with the when you wanted to generate the EMF, either you should vary the flux or you vary that space. Either you vary the space area or and all. Okay. So that's why the flux usually when it is varying in the area, if it is a varying means a sub phi is a phi m sine omega t, then the flux will be generated, or you change the area means this is a constant. Okay, the area at which it is lying, you change that area. Sometimes like this, sometimes overlapping like this, sometimes what is here like this. So this area is actually varying. So that's the two ways to generate the EMF itself. Okay, getting my point.
Okay.
So
Yes, sir.
in the DC terms, there will be no flux generation, there will be no EMF generation. Okay. But in the AC form, there will be flux because it is sinusoidal varying terms. So the EMF flux is varying. So that's why the EMF will be generated. Okay. Okay. Try to solve this problem. Have you got the answer? You're speaking something. If you got the answer, you can type in the chat box or you can just open your mic and ask, tell me.
You have to just apply KVL, correct? It's simple and straightforward.
Yeah, what is the exact answer I want? Not KVL, it's a KCL at the node.
KCL, sorry, I'm sorry. I mean to say KCL,
Yeah.
right? It would be just root 2 1 is will be root 2 cos of pi by 4
Hmm.
plus j root 2 sine of pi by 4. Then
Hmm.
you subtract IRL from it. That is root 2 cos of minus pi by 4.
Well, can
So
you
root,
give me the exact number?
okay.
Okay.
The final answer is 2 angle pi by 2, sir.
2 angle pi by 2. Okay. Anybody else?
2 angle 90, sir.
Okay. I got again a same answer as 2 angle 90 degree. Okay. Anybody else who is trying? Okay, let me give the solution for this. You can directly, if you see that at node, particular node A, the IS, because when you apply the KCL here, IS will be equal to IS in the phasor form, okay, will be equal to IRL plus IC, okay. It is asking basically what is the value of IC. IC will be equal to IS minus IRL in the phasor form, okay. So the IS is already given, it's a root 2 angle pi by 4 minus root 2 angle minus pi by 4, okay. You can directly find it out like this: cos pi by 4 minus j sin pi by 4 minus root 2 times cos of pi by 4 minus j sin pi by 4. Okay. When you add both terms, this cos terms will get cancelled out. It will become root 2, 2 root 2. This
No,
is
no,
minus.
you did. It should be plus plus j sine pi by 4 because it is root 2 angle of pi by
Okay,
4.
okay, yeah, yeah, yeah. This is plus. Okay. So it means that this positive terms will be cancelled out. So this is a 2 root 2. It will become minus root 2 here, plus here, minus here. So it will get cancelled out. And here it will become minus, this minus become plus. So it will become 2 root 2 times of j of sine pi by 4. Okay. So sine power pi by 4 is actually j, and this will be root 2, and root 2 will be cancelled out. It will become 2j means 2 angle 90 degree. Okay. So specifically, I have kept this question for the visualization. Basically, if you try to draw the phasor of this, the root 2 angle pi by 4, because it's in the RMS value, it is being represented. So when you draw the phasor of this, it will look something like this: root 2 angle pi by 4. What about root 2 angle minus pi by 4? Root 2 angle minus pi by 4. Something like this. Okay. What is the value of I?
Minus pi by 4, but that means it should be in opposite direction of that, no, sir.
Yes, so I am taking this as a reference. Okay, suppose I am taking this as a reference, it means that anti-clockwise direction it was positive plus pi by 4. It means 45 degree. But when you are negative, it means that either you should take in the means minus direction here. Means when you it was rotating anti-clockwise, now it is rotating clockwise. Okay, minus pi by 4. So that's why
Well,
it is,
I just want to say something. Reference is 0 degrees, right?
yeah,
So plus 45 will be above that, minus 45
yeah.
will be below that, right?
No, no, no. It means that suppose the angle which you are taking, it is reference is zero, no?
Yeah, yeah.
So
So minus 45 will be, it will be clockwise, right?
yeah,
It will be, hmm,
it is actually clockwise.
correct.
Have you seen? This is zero reference. This is a 45-degree opposite direction in the anti-clockwise, and this 45 is in clockwise direction, but in the reverse direction. Got my point? When you're trying to draw the phasor, always you take the anti-clockwise direction reference, okay, from the 0 degree reference, means 45 degree, 90 degree or something. Okay. When it is positive, means it is negative, it means that clock is rotating something like this. It means that it first moved here to 45 degree. Got my point?
Once again, sir.
Okay, let me
The
explain again.
graph alone, sir.
Okay, let me explain again. Suppose what I am telling, because suppose this is a zero reference, means some magnitude and 0 degree angle reference. Okay. When you are rotating anti-clockwise direction, it means that some sub angle, sub positive angle. Okay. When you are rotating in the clockwise direction, it means some negative angle. Okay. Suppose in this question, the angle was root 2 times of pi by 4. Okay. So I have represented root 2 angle pi by 4. When it will be a root 2 angle pi by 2, it will come here, root 2 angle pi by 2. If it could be a root 2 angle 180 degree pi, it will come here. So what about when it is negative? So it will come like this, root 2 angle minus pi by 4. Magnitude is positive, okay? Only thing we are representing here is the angle. When the root 2 angle minus pi by 2 will be represented like this, and the root 2 angle minus pi or pi will be similar values, it will come here, okay? What happen when we do the minus root 2 by pi by 4? Okay, this is positive. Then it will become 180 degree shift here. It will become minus root 2 angle minus pi by 4. Okay, got my point.
Yes, sir.
Okay, so this is the way to represent how the angle when you are taking in the positive direction, angle you are taking in the negative direction. Now the thing is, when you see the IC is basically IS minus IRL. So this is so let me take another pen. So this is the basically the positive part because root 2 angle pi by 4, it is IS. Okay. And this is the IRL. This is the IRL. but when you are adding up, it is minus times of IRL. So it means that ki minus times of IRL is coming here. Okay, so this is the line of minus IRL. So when you wanted to find it out, what is the net value? Because it is also 45 degree here, and this is 90 degree. So with respect to 90 degree, this is also 45 degree, and this is also 45 degree. Okay. So the net, if you see, this is a 45 degree, this angle is also 45 degree. So the net will come something at the 90 degree angle. Okay, like this. Okay, so that's why if you see the answer also, it is coming at an angle of 90 degree, but it is positive. It means that it is in the anti-clockwise direction. Okay, so magnitude means you can use that formula, that root of x square plus y square plus 2xy cos of angle, cos of theta. So here root 2 of square, because the 1 of RMS square is root 2 of square plus 2 times of root 2 multiplied by root 2 cos of 90 degree, because the angle between the both the phasors, root 2 angle pi by 4 and minus root 2 angle minus pi by 4, it is actually cos 90. It will become 0. So it will become minus 2 plus 2, 4, it means become 2. Okay, so that's why here the magnitude is coming 2 and the angle is coming 90 degree.
To
Getting my point?
find the to find the magnitude, we should use that formula.
Yeah, for finding out the magnitude, you can use this. This is known as a rectangular Cartesian means method to find out the what is the magnitude basically. Okay, means a rectangular form, or you can say the trapezoidal rule or anything and say, but the formula is remains same. When you have the two phasors and some angle in between you have given and the magnitude you know, you can find out what is the magnitude of that angle. For finding out the angle, there is a different mechanism also there. Cos inverse something equation is there. Okay, but in this question it is simple because this is also 45 degree angle, this is another side also 45, so in between it became 90 degree. Okay, any doubt in this, anybody?
You can use that IS is equal to IR plus IS in that formula also, no, sir?
Yeah, you can use that. You can
Okay.
use the both the formula, but I am because every question has a two different perspective to see, no? So this is another view to see this problem. If you see the directly from the phasor analysis, just put the magnitudes and see the angle, and you can get the directly the answers. Okay. Let me move to the another problem. Try to solve this. Any answer?
Anti-clockwise is positive, no, sir?
Anti-clockwise is positive. That's true. Anti-clockwise, usually assume that it is positive.
Option A, sir.
Okay, I got one answer. Anybody else?
Third one, sir. C.
Okay, I got one more answer as C. Anybody else? Take your time. There is no issue in time. You can take. Okay, let me give the solution for this. Okay, we will go through the by visualization. Okay, by which is lagging, basically, which is leading. Okay, so let's first draw the graphs. Basically, it's a cos graph, and this is second one is the sine graph, but the frequency is usually both of them are same. That is 100 pi omega. Omega is constant for both. When you see that ki cos graph will look like something like this. Okay, So this is minus 90, and this is plus 90, and this is 180, and this is 170. How the sine curves usually look like? Sine curve usually look like this. Okay, the sine curve is moving here 180 degree, and this is 0 degree. Okay, so let me take another pen. Okay, so how to draw this sine omega t plus pi by 4? Because sine is moving from here 0. So how it will move? It will move from here 45 degree. So it will move something like this. Here the angle is 180 degree plus 45 degree. Okay. So there are two concepts which I have told in the last class, how to decide whether one is lagging, one is leading.
So there
Always,
will be only 180 degree now, sir,
yeah,
because we have to come to 45 degree.
yes, because the sine angle, if you see this a plus pi by 4, it means leading. Getting my point?
No, sir, we have took that that red color angle will be 180 degree now, sir. Why 180 degree plus 45?
No, see, because it is leading by 45 degree, na. So each place, because each place it will become like this here. It have leaded, no? Because when was the zero reference? Zero reference was added up to plus 45 degree. Okay, it was shifted by 45 degree. At 180 degree also, it will be shifted by 180 degree plus 45 degree. At 90 degree
Okay.
also, it will be shifted by 90 degree plus 45 degree. Getting my point?
Yes, sir.
Okay, so that's why at each point of time, whatever was their angle initially, it will get time shifted by 45 degree. Okay, so now if you see the sine curve is usually looking like this. Okay, but if you see what I have told in the last class, when you are taking the leading or lagging concept, leading or lagging, you always see the positive slopes or you see the negative slopes. If the both are increasing, if both are decreasing. Okay. If you see this is the cos graph and this is the sine graph plus 45 degree shift, plus 45 degrees shift. Because let me take another pen here, take blue one. Suppose if you see here, this is the increasing slope here, cos of, and this is also the increasing slope of sine, but time shifted by 45 degree. When you see the angle in between them, it is usually coming out to be 180 degree plus 45 degree. There will be no magnitude shift is happening. Okay, so magnitude whatever was there initially, that 10 root 2, it will come the exact value 10 root 2. Okay, there will be no time shift in between or no magnitude shift. So the both options, this C, B and C will be discarded. The magnitude will be same 10 root 2 and 10 root 2. Okay. So here the 180 degree plus 45 is coming. So how to represent that? Because this was the cos is the reference, so it is leading by 180 degree plus 45 degree. So answer will come like this. Angle 180 degree plus 45 degree. Okay. But nowhere, no option is actually matching up. Okay. So let's see in the minus sign terms. Okay. Minus sign term is, suppose this was the cos and this was the minus sign. This is the, let me take another pen. So this is the sine graph. So this is 90 degree and this is 180 degree. What is the minus sign here? Minus sign will look like something like this. Minus sign will be like this. Okay. When the minus sign will be 45 degrees shifted, it will come like this and it will like this. It will move something like this. Okay. But in this situation also, if you see the decreasing slopes, the decreasing slopes here, let me take another pen here so that black here. If you see the cos is decreasing here and the sine is decreasing here, negative sense, sine is decreasing here because it is 45 degrees shifted. I'm considering in the magnitude terms. Initially, I have considered in the phase term. So how to represent that? Because cos was 10 100 root 2 angle 0 degree. It was reference. Okay. Now if you see that it is coming minus 10 root 2 sine term angle 45 degree, because this is also decreasing slope here. This, if you see the sine term, and this is the cos. So both are decreasing, but both are time shifted. So sine is actually minus time shifted by 45 degree, but the magnitude is coming negative. But the options, if you see here, the options, there is no negative is here. Okay. So it means that the all options are incorrect. Okay. What was the correct answer? It will be minus 10 root 2 angle pi by 4. Okay. Getting my point? Let me explain again this part. Let me explain again. What I have told that this was the sine curve. This is the sine curve. What will be the minus sine curve? Minus sine curve will look like something like this. This will be minus sine. How the minus sine plus 45 degree will look like? Minus sine 45 degree will look like something like this. This was the 45 degree, and this is the 0 degree. Okay. So now if you see the how the cos will look like, let me draw the cos. Cos usually look like something like this. It is moving 90 degree from here. So this was the 90 degree, and this is minus 90 degree. What I have told, always take increasing slopes or decreasing slopes to find it out the,
Under the degree answer.
yeah, minus sign means negative, means magnitude wise I am changing. Magnitude I have changed minus to see how it is happening, whether it is coming leading or lagging.
Okay.
Okay. So because the phasor it is already there, 10 root 2. I wanted to say how it look like when it is minus 10 root 2, kind of. Means this visualization, if you can see that. So in this also, if you see the, suppose I am taking the decreasing slope. Let me take this. So if you see the cos is decreasing here, cos is decreasing here, and the sine, this is a minus sign, which is 45 degrees shifted, it is also decreasing here. But if you see that the cos is actually leading here, okay, it means that it is lagging. Sine is actually minus when you are taking, it is lagging. So it will look like something minus 45 degree. But in the magnitude terms, it will become like this, 10 root 2 minus. Okay, because it was already referenced that it was positive 10 root 2. But with respect to cos, it is negative, inverted, and also the time shifted by in the negative direction, minus 45 degree. Getting my point? Any doubt?
Why we are taking minus inverse of sine? So by keeping sine wave, we can't find us.
No, see, there is a methodology to find it out. This is the means greater side of visualization. Because if you see here, what I've told when you're taking the positive slopes, okay? So what it is coming here, 10 root 2 here, but the angle was coming 180 plus 45. It is actually a 235 degree angle, okay? But the problem here is that all the angles are given in the less than means less than 90 degree. It's a 45 degree or minus 45 degree, but it is not coming in the here picture. So what I have thought of, let's reverse the magnitude itself because it was 10 root 2 and this is both are positive here. Let's take one as a negative, and after that we will shift the angle and see the what is happening, because with respect to one I am finding, okay, then I have seen that another one is coming negative. When I'm taking as negative, it's a minus from the one reference, and it is coming angle as a minus 45 degree because it was lagging by 45 degree. So now it is coming at the correct that minus 10 root 2 angle minus 45 degree. Now it is coming less than 90 degree. But the angle is miss magnitude is negative what it was previous. Okay, getting my point? Because initially it was 10 root 2 angle 90 degree plus 45 degree. Now it is coming minus 45 degree, but the magnitude is reverse. Let me give you the some glimpse with respect to phasor. So when you will get the more clarity after that. Suppose this is a phasor, okay? phasor analysis. So what it was telling that one angle was cos. Suppose I'm taking cos as a reference. Okay. So what it was tell that ki sine is there. Okay. So sine was actually leading. If you see here, the sine was actually leading by 90 plus 45 degree. Basically, sorry, this is 90 plus 45 degree. No? Okay. So it will be 135 degree. So it was leading by 135 degree. So if you see draw here, the cos was the reference. So this was 90 degree and this is angle is the 45 degree. So this whole is the 135 degree angle. But it is angle because it was 10 root 2. So angle was coming 10 root 2 angle 135 degree. But what happens when you're taking the reference? Suppose I'm taking is making is 10 root 2 as a negative. If you're taking negative, it will come like this here. 10 root 2 minus. But the angle was 45 degree basically here initially. But now if you see the angle is coming minus 45 degree here. So that's why I have took as a minus 45 degree, which is coming similar to that what is we have got from the curves itself. Okay. It was actually negative of that. With respect to cos, I am finding out that it is minus 10 root 2 angle minus 45 degree basically. Getting my point? Any doubt? Okay, let me move to the another problem. Okay. So try to find out the RMS value of this. It's a very easy problem. Anyone? This kind of easy problem, I guess. Okay, I got one answer as option A. Anybody else? Any other answer? So let me give the solution. Listen here. So if you see in this question, the RMS value basically when the same frequency components are there, suppose there is one DC component is there. Suppose this is A plus B sine omega t plus C sine omega t plus D cos omega t kind of. So RMS value, if you see the frequencies are same in the both, okay? So the RMS value will be equal to, if it is a kind of, so it will become A square plus B square plus C square plus D square by 2, okay?
So how you wrote that formula, say A plus B sine omega t?
Though this is the just a generalized equation I have taken. Suppose this is a generalized equation. A kind of problems. Suppose any question will be something like this: 3 plus 4 sine t, or one will be 4 plus sine t plus cos t plus cos of uh, something 2 times of cos t, kind of. This is just a generalized questions I've taken, generalized form. Then I wanted to give how to find out the RMS value basically. Okay. But the thing here, you have to see that generalized form is like this: root a square b by root 2 of a square, because b is the maximum value, and the RMS value b by root 2 divided by c by root 2 of a square plus d by root 2. When you solve it, it will come to something like this: the b square plus c square plus d square by 2. Okay. But here is a one catch is there. This formula is applicable when the frequency is constant, when omega is constant. Okay. If it is given as sine 2 omega t or sine here 3 omega t, you cannot use this formula in that situation. Okay. Then you have to go by the conventional method, by the equations itself. Okay. But if you see in the question, it is already saying that there one frequency and one DC component is there. So the RMS value will be coming like this. RMS will be 3 of square plus 4 by root 2 of square. It will be equal to 3 square is a 9 plus 4 by square is a 416 by 2. It will come out to be 17, root 17. Okay. Any doubt? Just remember that okay, if the frequencies are constant in the overall equation, you can use that okay, A DC square plus RMS of square, means if the maximum value is given, maximum divided by root 2 of square, or RMS is given, directly the RMS of square. Okay. Let's move to the another problem.
When omega is not equal,
Then you have to
how
go
to
by
solve?
the conventional method. Conventional method means the RMS value is usually 1 by t uh, root of integration 0 to t of something, suppose x of something a square, x sine omega t is there, then of square d omega t. This is the RMS value. Then you have to go by this equation. Okay. So this is the RMS value to find out the what is the value of RMS square. Okay, 1 by t, 0 to t, whatever the time frame is there, and then x sine omega t of square. That is the value, that is a ut basically of square and d omega t. This is a conventional way to find it out. But when it is sinusoidal and DC terms are there, you can find it out from these equations.
Okay, sir.
Okay, let's move to the another problem. Try to solve this. Here the VR is given. VR means this voltage is given as 5 volt. Let me take another pen here. Red. VR is given as 5 volt, and VC, this VC is given as 4 sine 2t. You have to find out what is the value of VL, this voltage. Priyavrita, can you close your mic? Priyavrita Mohapatra, can you close your mic? Important hint is there, as apply the KCL here. You will get the answer. Okay, let me give the solution for this. Listen here. Okay, stop solving. Just listen what I'm saying. What I have told, you have to apply the KCL here. Okay, but you have to find it out. You have to find out what is the value of VL basically. Okay, when you are applying the KCL at node A, the KCL at node A, in this situation, the current, if you see the circuit, how it is looking something like this. This was the case, and this was the node, and this is the capacitor, and this is the resistor here, and this is the inductor here. Okay. So node A means KCL when you're applying, it means that summation of I will be 0 at the node A. Okay. If you see here, the 2 amperes current is coming here. That is already being shown. But if you see the VR is given, VR is given as 5 volt, and the resistance is also given in the positive negative. Okay. So the resistor which is given here, so the current you can find it out from here that I will be equal to V by R. That is V is given 5. The resistance is also given. The 1 ampere current is flowing from here. So 1 ampere will flow like this, and 2 ampere is flowing like this. If you see the capacitor voltage, VC is given. VC is given as 545 sine 2t. Okay. So the current will be equal to I is equal to C dV by dt. C is given. C is 1 farad. Okay. Multiplied by dV by dt. If you differentiate this voltage, it will come out to be 4 multiplied by 2 cos 2t. It will be equal to 8 cos 2t. Okay. I will be something like 8 cos 2t, and VC will is 4 sin 2t when it is given. Okay. So it
Sir, we can't use I is equal to VC by ZC, J omega C.
J omega c. You can use. Let me give me 1 minute. One call is coming. Give me. हाँ भैया. हाँ ये ट्यूटोरियल सेशन चल रहा है मेरा. 8 बजे तक चलेगा. अभी तो पॉसिबल नहीं है. अभी पॉसिबल नहीं है. अभी मैं लेक्चर में हूँ. अ, हम्म. अब किसी और को कॉल कर दोगे क्या? मेरे ही ड्रॉर में पड़ी हुई. हाँ, मैं लैब में हूँ. मैं ट्यूटोरियल सेशन ले रहा हूँ ना. क्लास चल रही है ऑनलाइन. ठीक है. Okay, let me explain that. You can use that. You can use the I is equal to that C by what you are saying, that VC by j omega c. That is true. You can use that. But the problem here that suppose this VC by what I have told 1 upon SC or divided by minus j upon omega c. Okay. From here also we will get the same value. Why I am saying that? If you see VC divided by minus j upon omega c, omega it is given that. What is the omega? Omega is 2. What is value of C? C is given 1. Okay. So VC divided by means 2 already came into picture above, and divided by minus J. Minus J means angle is shifted by 90 degree in negative direction. And if you're taking the upper side, it will become 2J VC. Okay. So it means that it is 90 degree shifted into anti-clockwise direction. That is same now, because it was sine initially, it became cos. Okay. And it also multiplied by 2. Means 2 multiplied by j multiplied by, that is 4 sine 2t. Okay. So that is already 8j sine 2t, and j means it is anti-clock time shifted. It means it became cos. Okay. It means that the same value, same answer will come into the picture when you take the minus j upon omega c also. There is no difference in between that. Okay. Got the point?
But we are getting in sine, you got in cos, na, sir.
Yeah, so because it j is there, no? So if you're taking the cos as a reference, or you're taking the sine as a reference, now the j multiply. When you multiply it by j, it will rotate by anti-clockwise direction in 90 degree. So the sine will become cos. Okay, are you getting my point? This is already angle j. J means it is rotating by 90 degree. So initially it was sine like this. When you rotate it by 90 degree, it will become something like this, cos. Okay, means time shifted by something like this, cos. Okay, got the point? Because it became the 90 degree plus angle of 90 degree. So it became
Yes, sir.
like cos. Okay, so the same value will come into the picture. So I we have got at 8 cos 2t, 8 cos 2t. Now the thing is how to calculate, because we have got the all the three currents. This is a positive, this is negative, and this current is flowing out of that network. So this current is actually flowing out of that, and we got at 8 cos 2t. Okay. So the thing is summation of I usually is equal to 0. So let me take another slide for that. So it is like this. So current is, so from here it is coming 2 amps at this node, and one current is coming from the above side. What is the value? It is actually 1 amps. What is current going out of that network? It came out to be 8 cos 2t. 8 cos 2t. Now you have to find out what is the current actually here, I. So it's just a KCL. Summation of I is equal to 0. Summation of capital I, let's take. What I have told, always assume that going out of the network current as a positive. Okay. So this is minus 2. This is minus 1 plus 8 cos 2t, and the current I plus is equal to 0. So I will come out to be 3 minus 8 cos 2t. But the question what is asking, it's asking VL. Okay. So it was like this. It was circuit was like this plus VL something, and the current is flowing like this. Okay. It was asking what is the value of VL basically. So the VL will be equal to L di by dt. L, what is given L? L is given 2 Henry. L is given as 2 Henry. So just differentiate this current. Okay. Let's differentiate. It will become VL is equal to 2 times of that DC. If you differentiate, it will become 0. And this minus 8. This is 2. Cos become minus sine 2t. It will come out to be 32 sine 2t. Okay. That is same answer if you see here, the 32 sine 2t. That is the B option. Any doubt in this?
We can take like L by I, na, sir.
L by I means
Like, B I
that,
by J omega L.
yeah, you can use that. I by here for finding on the VL is equal to I by j omega L. Here also you will get the same answer. J here is also 2, L is also 2. I we have got as 3 minus 8 cos 2t. Okay. Then but the problem here is the day differentiation also. For finding out the voltage. Sorry, here is the, sorry. This is actually wrong. Wait, let me remove this. Let me remove this because the voltage VL is equal to j omega L multiplied by I, because impedance value B is equal to IR basically. So the I will j omega here is the J2, and the L is also given 2. Okay. So multiplied by I here. But the thing here is this is not the exact equation because j omega L multiplied by I. I here, if you see, I is here 3 minus 8 cos omega t. Okay. And also in this equation, the 3 minus 8 cos 2t multiplied by 4 j. Okay, when you take down these equations as well, you will get the same answer because here the DC term is there. So how the phasor will come out to be? Phasor will come out something like this. DC, some DC component will come here. Like if you see here, the 4j, 3 means 12j. Okay, 12j means some DC component and it is a at an angle of 90 degree, 12j. And one cos term is there. So how to represent that as well? So you have to take the DC like this and which was shifted by 90 degrees. It doesn't make any sense. Is how to rotate this by 90 degrees. This will be rotated something like entity, it will become like this. So it is not making sense. You can directly use the differentiation, you can use that. Okay. This is the formula that you will get the same answers, but the thing is ki how to when you rotate it and then you will add the cos as well, then it become very difficult to add both the equations and get the answers as well. Okay. Because when you're adding the 12j with the cos, it will become upper shifted. So how to add them, it will become difficult. You can just directly differentiate and you can get the answer. Okay. But the answer will come same in both the situations.
I got 12j plus 8 sine 2t. I
Yeah.
took 8 cos instead of 8j sine 2t I took, sir.
Okay. Always see that when you are having this s terms, this suppose yes term is there, it means that ki differentiation is there or j omega term basically. If you are taking 1 upon j omega term, it is basically 1 upon s. It means that it is integration. Okay. So this become usually difficult to multiply with usually that a 4j when you multiply it by 3 minus 8 cos 2 omega t because one it is in the time domain and other is in the j domain. So it becomes very difficult to add both the terms because you have to convert both into the time or both into the j term. So usually what happens that j means differentiation j omega, it usually differentiated. Here also if you see VL is equal to j omega L multiplied by I. J omega means differentiation. Just differentiate one time of I multiplied by L, you will get the answer. Okay? This is an easier way to get to. Getting my point?
So we should differentiate if j comes, sir.
Yeah. If it is j omega, not just a j omega when it comes, or yes, it is represented in the Laplace domain, just differentiate it.
Then VL will be simply di by dt, na, sir?
Yeah, simply di by dt, but L was also there, no? So this is the exact equation. If you represent the L di by dt, it will become L multiplied by j omega multiplied by I. That is j omega L multiplied by I. That is same equations, no? Similarly, you can imagine that like this also, because this equation and this equation both are same. Okay, that's the
So,
differentiation. It is j omega.
so if time and j comes in same time, we can
No,
use
you
that formula. VL is equal to L di dt.
this I am doing
Omega.
just for the simplicity, but you cannot add multiply the time domain terms. This I am doing because I wanted to show you that this could be represented in the J form, but always add the time domain terms because there is a different time frames now. J is a different time frame, different domain basically. Yes is different domain. Time is different domain. Time domain, yes domain, j omega domain, j domain. They are the different domains where to do because both are integrated but with some assumptions, which is not applicable everywhere. So try to take down each system into one form, either j omega, either time domain, or anything, or either phasor. Don't mix the phasor with the time domain frame. Phasor is a different, you cannot multiply T, J, something kind of. So T, J, 2, this is doesn't make any sense. This just I have kept here in this question just for the simplicity, which I wanted to say that if it is you multiplying by J, it is coming like this. But it is something like this, minus j upon omega c. Okay, that is basically j omega c. It means that it integration kind of thing. So that is the thing. So always see that ki always use one domain for the analysis, not the mixing of the both the domain, time domain and j domain. Okay,
Yes, sir.
okay. So let's move to the next problems. This I will give the glimpse, just and then move to the another slide, which will help you to solve the assignment 5. Okay. This I will solve by myself itself. So it is asking in this, there is a two couple inductors are there, L1 and L2. There is the mutual inductance is there. It is asking what is the relation between the M, L1 and L2. You you have seen that M is equal to K root L1 and L2. K is the coefficient of coupling, and K usually lie in between 0 to 1. Okay, K can be 0 or can be 1. So if you replace this K from here, it will come out to be M by root L1 by L1 L2 in between 1. So M will come out to be in between L1 and L2 and in between 0. Okay, so the if the options, if you see, the D option is matching. So always see the coefficient of coupling is always lie in between 0 and 1. So based upon that, the M will be less than or equal to root L1 and L2. Okay, let's move to the, any doubt?
No, sir.
Okay, let's move to the important part of assignment 5. So this was the one question in the assignment 5. Okay, and this is our main goal to solve this kind of problems because this is usually important to solve the assignment. Okay, so let's make the some base out of that. Then we will jump out to this problem and see what could be the partial solution to and how to find it out. Okay, so let's move from the basics to basics. Okay, just listen what I'm saying. So there are few theorems. Few theorems are there in the Laplace domain and in the delta functions also. This is a kind of delta function. Okay, so in each question there is a one means a theorem which is applicable, or you can say simpler form of why it is applicable. Okay, so from question to question I will solve the questions and will show you how to solve this kind of problem, and you just have to listen that, and then we will move to the final part to solve this kind of problem. Okay, you just have to listen because will not able to solve this. Okay, you just listen, and at the home you should try by yourself. You will get the means feel how to solve this kind of problem. See, this is the first problem. Here what is given? It is given that some integral terms are there. Suppose this is given as minus 5 to 6 e to the power minus 2t delta t minus 1 dt is given. Okay. So if the in the functions delta function is coming into the picture, how to solve this kind of? So there is a one theorem, minus infinity to infinity, any function ft is there, delta t minus k is there, dt. If k is lying in between minus infinity to infinity, then the solution will become like this. Just put the value of fk. The solution will be the fk. It means that if you are finding out, suppose in this question, if you see, you have to find out 5 minus 5 to 6 e to the power minus 2t delta t minus 1 dt. What is, could be the solution? If you see that k here is k is here 1. So 1 is lying in between minus 5 and 6. Means 1 is lying
Yes, sir.
in between minus 5 to 6. It means that what will be the answer of this function of k? What is the function here? Function e to the power minus 2t. Just put the value of 1 here. It will become e to the power minus 2. So 1 upon e square. Okay. So what happens when the k is not in the range? Suppose I have taken this minus uh, t minus 7. Then what will be the answer here? So the thing is, here the 7 is not coming in between -5 to 6. Just simply use the, it will become 0. Okay. Why I'm saying that? Because that delta t is usually like this. Okay. And delta t minus 7, because the range, because you wanted to integrate in between -5 to 6, and its area, delta t area is usually 1. Okay. When you are shifting it by 7 at 7, delta t minus 7. So delta came here. Okay. So it shifted to here, but you wanted to find it out the area in here itself. But the delta was lying outside of that range. So it means that its area will be 0 in the range of -5 to 6. Just remember this theorem, that ft delta t minus k dt, if the k is in between minus infinity to infinity, it will become fk. And if the k is not lying in between minus infinity or in some ranges, which is the integral is given, so it will become 0. Okay. Just listen what I'm saying.
Just listen what I'm
If you have any doubt, just let me know. Okay.
No, sir.
Okay. Just listen what I'm saying. You will get the feel of the questions. Okay. Let's move to this problem. This problem is in the similar manner, but here if you see the delta having the coefficient something, because in the previous problem which we have seen here, the delta having the t frame here is a 1. Okay, coefficient of t is 1, but in this problem the coefficient of t is 2. So in these problems what we do, usually we take the 2 out, t minus 1 kind of, now it become t. So delta, one theorem is there. This is the second theorem. Here the delta, if it is given as k times of t, it will be 1 upon mod of k delta. You can represent like this. Or you can see that delta k t minus 2 is there. Then represent it in form the k. It will become k if you take the common, t minus 2 by k. Okay. So it will become 1 upon k delta t minus 2 by k. Okay. So let's apply it here. What it will become? It will become 1 upon mod of 2. Now the integral will become like this: e to the power minus t delta t minus 1. Now you can apply that theorem which I have told. Okay, here the k is 1. It is lying in between minus infinity to infinity. Just put the value of 1 here. It become 1 upon 2 e to the power minus 1. It will become 1 upon 2 e. Okay, so the two theorems which I have told, uh, let me take another pen here and let me explain here. So first is minus infinity to infinity, ft delta t minus k is there. If k is lying in between the, suppose this is minus a minus b. If it's lying in between the a to b, minus a to b, it will become f of k, otherwise it is 0. And the second is, if the delta is a times of t minus k, it will be equal to 1 upon mod of a delta t minus k. Okay, these two theorems are there. Okay, now let's move to how to solve this problem. Here what is saying that current is given. Current is given as 5 delta t, and it is forced toward the capacitor. It means that current is like this. Current is like this, and it is forced toward the capacitor. And it is asking what is the voltage across the capacitor. VCT it is asking, and the IT is given. So you already know what is the value of voltage. Voltage is actually equal to 1 upon C IT dt. Okay. So 1 upon C integral of 5 delta t dt. From where to where? Minus infinity to t. Minus infinity to t. Now here the third theorem. It's a basically third theorem. Basically, When you differentiate the ut is the ut function look like something like this. Ut is like this. Ut is one constant, one, and moving from the zero reference frame and till the infinity. Second is the delta which I have already shown. This is the delta t, and it is lying actually at the zero value. Third is the ramp function. Ramp function is will be like this. But slope is something rt, and the slope is something will be there what is given. So this is to find, this is the unit function, this is a delta function, and this is the ramp function. Okay, three kinds of function exist. Okay, so when you are moving from differentiating d of dt ut, it will become delta function. When you are differentiating delta, it will become 0. And also when you are differentiating ramp function by dt, it will become ut. So the hierarchy look like something like this. Hierarchy is this. This is the differentiator. Okay. When you differentiate RT, it will become UT. When you differentiate UT, it will become delta T. Reverse also happen when you integrate. When you integrate delta T, it will become UT. When you integrate UT, it will become RT. Remember this. Okay. So let's solve this problem. Here in the question, it is saying the integral of delta function. Integral of delta function, it will become UT. What I have told from the here itself. When you integrate delta t, it will become ut. So similarly, when you apply in this problem, it will 1 upon c minus infinity to t 5 times of delta t dt. So it will, because it will become ut. So this become minus 5 by c, and this minus infinity to t delta t will become ut. So the correct answer will come out to be like this. So what I am saying that d by dt of rt will be equal to ut, and d by dt of ut will be equal to delta t, and also integral of delta t.
Is unit function, sir.
Yeah, this is a unit function. This is standard functions basically which you will encounter in the many places. So delta t, integral of delta t dt will become ut, and delta of ut of the integral, it will become ramp function. Okay, this is a hierarchy basically. So why I am giving you this kind of theorems? This is very helpful to solve few of the problem. This is basically one this kind of problems. So let's move to the what is actually important here. If you see this question is given as the unit impulse response of a system is given. It means that delta t is given. What is asking here? The step response. It means that the delta function is already given. This is delta t, and it is asking minus infinity to t delta t, which is usually equal to ut. Okay. Now one catch in this equation that it is asking t greater than equal to 0. It means that it is not starting from minus infinity. It is starting from 0 to t. Delta t dt, which will be equal to ut. Step response. So ut, how to find it out? Put the value of delta t from here in this equation. It will become 0 to t minus 4 e to the power minus t plus 6. If you feel any doubt in between, just stop me and ask. Okay. Okay. So this is the 0 to t minus 4 e to the power. Just I have kept this equation of delta t. Let's integrate minus 4. What is integration of e to the power minus t? It will be come out to be e to the power minus t divided by minus 1 0 to t plus 6 uh, e to the power minus t 0 to t 4 e to the power minus 6 e to the power minus t. Okay. 6 e to the power minus 2t divided by minus 2 and 0 to t. Let's put the values. It will become 4 e to the power minus t. When you put the 0, it will become minus 1 plus 2, 6. 6 divided by 2, it will become 3 minus 3 e to the power minus 2t minus 1. When you solve, it will become 4 e to the power minus t minus 4 minus 3 e to the power minus 2t plus 3. What is the final answer it is coming? 4 e to the power minus t minus 3 e to the power minus 2t minus 1. So the a value, if you see, the a value is coming 4, b value is coming minus 3, and c value is coming minus 1. So the second option is actually correct. So the important point is to remember in this problem that to feel that if you differentiate the ut, you will get the delta t. When you integrate delta t, you will get the ut. Okay, that is an important concept. Okay, so let's move
Sir,
into
how do you find the given function is delta t?
how to use because delta t is already given here. The response which is we have found it out that delta t, that is a unit
How do you
impulse.
find the question is delta t, sir?
Ha, always see in the question. If you see in this question, let me take another pen here. Red, black here. So if you see that this is the written here unit impulse response, it means that there is a one system in between. You have given the input as delta t and you got some output. Suppose I am getting yt. Okay. Unit impulse response. It means that input was delta t and some response yt I have got. Okay. So that's why the input was already been passed through delta t. If it in the question it was saying unit step response. Okay, it means that the system what we are having, his input was ut, and after that you have got the some output y dash t. You don't have to go into the depth. You will read it in the signal system chapters. Just see that what was the input basically. Here the input impulse was given to the some system and the response you have got the yt. Same if you see what is asking the what is a step response. Okay. Step response with the input was already delta t initially. It was asking when it is the ut, what will be the response. It means that the ut was already the integral of delta t. You just at the input side, you just integrate, you will get the same answer. Okay, getting my point. It means that suppose this is the HS one equation, ys by xs. Xs is the input and the ys is the response. Initially, it was suppose it was xs. Now, what is asking? What is the impulse? Means step response. Step response means differentiation. Integral basically. So it just means what is the you have done the integral of that multiplying or 1 upon s ys by s integral of what was the initial response, just integrate it by that. Okay, the third kind of problem which is all very important for solving the that original problem is this. If you get the differential equation in the form of like this, you have to convert in the form of Laplace transform. Basically in the S domain to simplify the equations. Okay, let me solve this. If you see d square by dt square, replace it by s square ys minus s y0 minus y dash 0. This is standard form. If it is a d cube by dt square, in that fashion s cube by ys minus s square times of y0 s times of y dash 0 minus y double dash 0. This is a conversion from the time domain to S domain. Y0 here is the initial value. 0 means yt, initial value. Y dash means differentiation of y, then putting the value of 0.
What is S domain, sir?
S domain means this is a Laplace domain. This is one conversion form that is, suppose the some function is there ft. You have to find out Laplace domain. This is a 0 to t ft e to the power minus st dt. Basically conversion from the one domain to the another domain for the better analysis. So this is already in the time domain. For solving this time domain equations, this I have given in the tutorial session 4, 3 basically. So that is very lengthy process. Okay. But when you go into the S domain, this will be the S domain. Simplification becomes easy. From the question itself, I will show how it is becoming easy. So first, let me explain that. Okay. So d to the power 4y or dt square, the similarly fashion s to the power 4ys minus s cube y
dt square or dt per 4, sir?
vt by 4 means
dt square or dt per 4, sir?
4 d to the power 4y.
Down, sir, dt
Ah,
per
it will be 4 and here also 3. Okay. Means differentiating 4 times y basically. Okay. So how to solve this kind of problem? Let me, because you have already got the few of the sense that uh, conversion from a time domain to Laplace domain. Okay. Let me solve this problem first. Then I will give you how to approach the other problem. That is the main problem which was there. So when you convert here, it will become s square ys minus s y0 minus y dash 0. This is the d square y plus 2 times of dy by dt is s times of ys minus y0 plus ys because the y t is there, yt will become ys. And the delta t in the time domain frame, it is 1. Okay, in the S domain. Ut is 1 upon S. Rt is t, basically 1 upon S square. Okay, so it will become 1. So when you put these values, y0 is equal to
minus
1.
will come now, sir.
Yeah,
Minus will come now, sir.
no. Minus will not come. Here the plus yt is there. No?
Ah, okay, sir.
Okay. So y0 minus is minus y2 and yt. Basically, it is given as y0 is equal to minus 2 and y dash 0 is equal to 0. Put these values because it was asking what is the numerical value of dy by dt. Okay. Let's find it out what is the value of ys. Then we will convert in the time domain and differentiate easily. Let's put the values s square. What is the value of ys? We don't know. We have to find it out. What is the value of y0? Y0 is minus 2. Y dash 0 is given 0. It is 0 here and plus 2 s times of ys minus y0. Y0 is minus 2. So it will become plus 2 plus ys is equal to 1. Okay. Find it out
Y
value y
dash of 0 will come now, sir.
here
There plus 2 is y of s minus y dash of 0 will come now, sir.
minus y
In
dash of
formula.
0. Here now y dash 0 is 0 because it is given as y
Down,
dash. It is given y dash 0 is equal to 0. So that's why I have kept here is 0.
in
But
form and down, there's
here y
s
0.
y.
This is y 0
Uh,
only. This is not y dash 0.
for everything, it came at last y dash of 0 now, sir.
No, not all. So if you see which I have given that, uh, Let me explain that. Because it's a very kind of because you have not know the signal system, that's why it is very difficult. Yt is ys, d by dt of yt will become s times of ys minus y0. If you use d by d square yt by dt square in the Laplace domain, it will become s square ys minus s times of y0 minus y dash 0. Similarly, when you do by d cube by dt square, it will become s cube by ys, s square by y0, y s times of y dash 0 minus y double dash 0. Getting my point? This I will share this slide. You don't have to go into the depth. Just listen what I have told him. Just you have to find it out. From here, take the ys common. Some equation will come. Then ys will come out to be like this: 1 upon s square plus 1 plus something kind of s plus s square plus 2s plus 1. So then there are some rules to convert from the S domain to time domain. Okay. In the lecture slide itself, it is given that how to convert from the S domain to T domain. If you see the lecture decks, what the professor have taught, then you will able to convert from the time domain to S domain or S domain to T domain. Just try to solve the from the S domain problems. You will get the feel. Okay. So this kind of problem will be attempted like this. I have kept the few more problem. Use that problems and try to solve. We will see in the next lecture. Let's move to this first problem, which was important to solve your numerical basically. So here, if you see here, it was question is saying that the switch is closed at t is equal to 0 and the capacitor was charged at V0 minus is equal to 30 volt. Okay, and there is no current across the inductor. So this circuit you have to convert into the S domain basically. Okay, so conversion it will become like this: L become SL, C become 1 upon SC. Okay, and if there is a current, initial current is there in the inductor, it will represent it like this. This will be, suppose the in I0 is 2, so it will become 2 by S, and this is SL. And it is given there some capacitor initially was there, so it will be represented by the voltage source. Suppose here it given 30 volt, so it will come out to be 30 by S here, and it will become 1 upon SC here. Okay, this is representation of the L in the S domain. This was the time domain because the I2t, T11, I1t is given, VCT is given. So this is a conversion from the time domain to S domain. So let me give you the exact circuit how it will look like. It will look like something like this. No initial current, it means this will be the SL 10S. Second, there will be no conversion in the resistor. So switch will be something like this. So here the voltage source will come, that is 30 by S, and one capacitor. Capacitor will be 1 upon SC. C is given. Okay. Now what you have to do in this kind of problem, just apply the KCL here. Assume this is the V. So V what will become? V divided by current. We assume that it is going out of that network. It will become 10S plus V by 41 plus V minus 30 by S divided by 1 upon SC will be equal to 0. Solve this problem and then find it out what is the value of V in the S domain. Okay. Then see that how to convert from the S domain to T domain. There are few formulas are there. Have a look by yourself and see the lecture slides, lecture deck, basically lecture means you will get the feel how to convert from the S domain to T domain and T domain to S domain. When you get this V in the function of S, you can directly convert in the T domain. Then you will get the exact equations like this. Okay. So this will make the system, means analysis, become simplify. Okay. Try to solve it by yourself. We will see in the next lecture whether how to, means if you feel that there is a, it's still will be with doubt. Okay. Okay. Any doubt?
So will you teach this question next session, sir?
Yeah, I will take this question in the next session and try to solve it by yourself, because what the methodology to be followed I have already given. Because if you see the how to convert when the initial conditions are given in the capacitor, how to convert in the S domain. Just put that values in that form and use the KCL. KCL and the KVL as the fundamental. Use that KCL and the KVL and then get the equation of V in the terms of S domain, then convert in the T domain and they do the analysis. You can find it out because V is already given. Okay. So from the V you will get this equation VCT. Then by matching you will see that what is the value of AV, what is the value of omega, what is the value of phi V. Okay, phase and all. So it will become simplify in the S domain to convert into the time domain. Okay, just see the formulas and all. We will discuss in the next tutorial session. Okay. Okay, that's all for today. We will meet in the next tutorial session. Okay.